How's it going, guys? This is a walkthrough of M4 for summer 2022. Okay, so we're going to go through all the questions and we're going to try to answer them the best we can. Okay, so let's take a look at the first question here. Okay, so a solid cylinder has a height of 12 centimeters and a cross-sectional area of 34.2 centimeters. Okay, so this is the cross-sectional area here, so it's just this area of the circle. Okay, so let me get my pen ready. Okay, so this is just our area of the circle here. Okay, the density is 0.83 grams per centimeters cubed, and we want to find the mass of the cylinder. Okay, so first off, we need to have a relationship between density, mass, and volume. Okay, and the units of our equation here, grams and centimeters cubed, kind of give us an answer. Okay, so density would be equal to mass divided by volume. Okay, grams is the unit of mass, centimeters cubed is the unit of volume, so density is equal to mass divided by volume. Okay, that's just in case you don't know the formula for density. All right, now we're looking to find the mass of the cylinder, so we want to have m by itself. Okay, so the volume is dividing m on this side of the equation. Okay, so if we want to move the volume over to the other side, since it's dividing on this side, it'll multiply on the other side. Okay, so then our mass will be equal to density multiplied by volume. All right, so next step, okay, we actually need to find the volume of our cylinder. Okay, because we know we have the density is now 0.83 grams per centimeters cubed. Our volume we don't know, and our mass we don't know. Okay, so let's take a look at our volume first. All right, okay, so apologies about that, just had a delivery from Amazon, so let's get back at it. Okay, so we need to have an equation for volume. Okay, volume of a cylinder. Okay, so the equation for volume of a cylinder, if you don't know, is pi r squared multiplied by h. Okay, so multiplied by our height. Okay, now our equation has already given us the area of our circle. Okay, so this part here is equal to 34.2. Okay, and our height here is 12 centimeters, so we can multiply by 12. So volume is equal to, 1 second, type it in my calculator here, 34.2. If my calculator would turn on. One's out of charge, and this is why we've got 2. So 34.2 multiplied by 12, that gives us 410.4 centimeters cubed. Okay, so we have our volume, we have our density. Okay, mass is equal to density times volume, so mass is equal to 0.83 multiplied by 410.4. Our mass is equal to 0.83 multiplied by 410.4. Our mass is equal to 340 grams 0.6. Okay, or 340.6 grams. All right, first question's not too bad. All right, so let's take a look at the next one. All right, so shares were bought with an original value of 1,600. Okay, the value was increased by 5% each year. All right, calculate the value after 3 years. So our original value is 1,600. Okay, and it's increasing by 5% each year. So if it's increasing by 5%, okay, and 1,600 is 100% of our value, and it's increasing by 5%, then our new value in year 1, year 2, year 2 and year 3, it'll be 105% each year. Okay, as we have an increase of 5%. So how can I increase 1600 by 5%? Okay, so I can multiply it by 1.05, which represents, in terms of percentages, 105%. Okay, so by multiplying 1600 by 1.05, I'm getting an increase of 5% on this value. Okay, now we're looking for the value after 3 years. Okay, so what we can do is we can just cube our percentage increase, and this is a simple way to wrap up this question. Okay, there is another method, so there is, which is essentially year 1 would be equal to 1.05. Okay, and that'll give us an answer. Okay, year 2 you'll do the exact same operation. Okay, instead of I'm preemptively writing 1600 again, we'll take our answer that we've just worked out, we'll multiply it again by 0.05, because again each value, or the value, is increased by 5% each year, so our answer will be increased by 5% again. So it is. Okay, and I'll call this answer 2. So year 3 will be this answer 2 multiplied by 1.05 again, and that will give us answer 3. Now you can see why I'm getting the cube root here is because the only thing that stays constant is our multiplying of 1.05, or multiplying to increase by 5%. All right, so we're doing this 3 times, so we can just do it to the power of 3. Okay, so instead of doing each line out, we can do it here. So the general equation that I would use for this would be the original value multiplied by percentage increase or decrease, and n, which is the number of years. Okay, this keeps it straightforward. Okay, so our answer in the end would be 1600 multiplied by 1.05 to the power of 3, which is 1852.2. So it is. So, and that's how straightforward this question can be. You can essentially just do it in this one step here. Okay, so let's move on to our next question. All right, so here we have a frequency table. Okay, so the first thing that I do when I see a frequency table is I'll fill in CF, cumulative frequency. Okay, and I'll fill in, since our minutes delayed in T is a range, I'm just going to write T here, and this will be my midpoint value. Okay, because we can't choose a value, we can't choose 0, we can't choose 20, we'll have to choose a midpoint. Okay, so I'm going to go 10, go 30, go 50, go 70, 90, and 110. Okay, it increases by 20 each time, so our midpoint would also increase by 20 each time. Okay, so let's read the question. I haven't even read the question yet, and I'm preemptively solving it. So the number of flights delayed at an airport were recorded over a 24-hour period. The number of minutes they were delayed is shown in the table below. Okay, so number of flights, that's just our frequency. Okay, so it's like a number of anything. How many, think about how many goals someone scored, that'll be the frequency of goals that they scored. Number of flights is just the frequency of flights. Okay, so essentially what they're saying here is there's been 31 flights that have had a delay between 0 and 20 minutes. Okay, so 31 times there's been a delay in between this range of time. Okay, same with here, 19 flights have had a delay of 20 to 40 minutes. Okay, pretty straightforward stuff. That's what it is. So let's populate our cumulative frequency column. Okay, so cumulative frequency always starts off with our first value of the frequency table, and then we just add the values as we go along. So 31 plus 19, that'll give us 50. 10 plus 50 will give us 60. 14 plus 60 will give us 74. 12 plus 74 will give us 86. Okay, and 6 plus 86 will give us 92. Okay, now the cool thing, or well, not cool but cool for me, our last value on the cumulative frequency value, our cumulative frequency column, is also what we call our sigma f. Okay, which is the sum of our frequency values. So this symbol here just represents sum. Sum means to add together. Okay, so whenever you see this weird shaped E, it just means sum. Okay, so I'm going to write this down here because for the question below, we're going to be working out our mean. Okay, I generally populate the table even before I start reading the question because that's the best procedure to go forward. It means you've got all the tools ready for you so that you can solve the question. Okay, so one of our columns is CF. The next column would be XF, or in our case, TF. Okay, TF. So it's going to be our midpoint multiplied by the number of flights. This will give us the total number of minutes delayed for that range. Okay, so the total number of minutes delayed would be 31 multiplied by 10, be 310. 19 multiplied by 30, that would be 600 minus 30, so it would be 570. 10 multiplied by 50, which is 500. 14 multiplied by 70, which will be 700, 710, so it'll be about 980. Just going to check that in my calculator. It's early on a Sunday, so my brain is still waking up. Okay, 980 is correct. So 90 multiplied by 12 will give us 1080, and 6 multiplied by 110 will give us 660. Okay, so once we have populated our TF, or this is commonly referred to as XF, I have just used our variable t instead of our variable x. Okay, these are interchangeable, so they are. Okay, so the question asks us calculate an estimate for the mean number of minutes that the flight were delayed. Okay, now how we generally find the mean, okay, is we'll do fx divided by the sum of fx divided by the sum of f. So in our case, it'll be the sum of TF divided by the sum of F. Okay, so again, this sum of TF is just us adding all these values together. Okay, so the sum of TF is equal to, I'm going to calculate that now, 310 plus 570 plus 500 plus 980 plus 1080 plus 660. So our sigma TF, our sum of TF, is 4,100. Okay, so all we need to do is populate our wee formula here. So 4,100 on top, sigma F is 92. So we divide by 92, and that will give us the mean number of minutes that flights are delayed. Okay, so 4,100 divided by 92, that'll give us an answer of 44.56 minutes. Okay, so you can fill in at the bottom here. I don't need to, I'm just going to keep it there. Okay, my exam isn't going to get marked, so there's no point in me doing so. So write down the modal class. Okay, now modal just means mode. Okay, a mode means the highest occurring or most frequent, okay, class. So write down the modal class. So we're looking for the class that has the highest frequency, okay, and for me that would be our 31 flights. So this will be our modal class here, 0 to 20 minutes, okay, because it's got the highest frequency out of all our classes, okay. So in this case I will actually write in just to keep it right, okay. So write down the class interval in which the median lies, okay. So if you're unsure of how to find the median is equal to n plus 1 divided by 2, and we'll be looking at our cumulative frequency column, okay. In this case, n is our total number of flights, which essentially is just our sum of f, our total frequency, okay. So it'll be 92 plus 1 divided by 2, which will give us 93 divided by 2. 93 divided by 2 is just 46.5. So we'll be looking for the 46.5th value in our cumulative frequency table. So let's take a look again. 46.5 is 46.5 in the range of 0 to 31. Now what about this range of 32 to 50? Yes, our 46.5 value would be in this range of values here. So our median class would be 20 to 40 minutes, okay. So 20t to 40, okay. Now just in case you don't know what I'm doing here, this cumulative frequency represents a range of values, okay. From 0 to 31, this one represents 32 to 50, okay. This would represent 51 to 60, 61 to 74, and on, okay. It's not visually represented in the cumulative frequency column, but that's what it actually represents, okay. So just in case you're wondering, I have this 46.5. So what does that mean? Does that mean 46.5 minutes? No, we'll look at our cumulative frequency column and try to find what value 46.5 is in the range of, okay. So let's move on to our next question. All right, so the graph below illustrates two different monthly tariffs, A and B, for a mobile phone, okay. Tariff A has a fixed charge per month plus a charge per minute for phone calls. What is the fixed charge per month? Okay, so let's think about this, okay. So if you had a fixed charge per month, okay, when are you going to have your fixed charge per month? So it is, are you going to have it when you've used 0 minutes of your calls, or 1,000 minutes, okay. The fixed charge is going to occur before you use any of your minutes, okay. Kind of think of it as if you were renting a van, okay. The fixed charge would be the rent of the van, so it is, and the additional charge would be the petrol that you're using to run the van, okay. But you have to pay that fixed charge to be able to use the van. Same situation here. Our fixed cost, our fixed charge per month, will be at times 0. So this is our A. At times 0, it costs us £20, okay. So that'll be the fixed charge per month, will be £20, okay. Next will be the charge per minute for the tariff, okay. So the way I like to look at this is charge per minute, okay. Charge per minute. So if we look, we've got cost here in minute. So essentially it's our gradient, okay. So the gradient of our curve. So it is. So what we can do is I can just go along here like this, go like this, and our gradient G is equal to rise over run Okay, so our rise here will be 20 to 45, so that's 25. And our number of minutes used, or our run, is 1,000. Okay, so for £25, I get 1,000 minutes. So how much do I get per minute? So let's get this. We'll put this into our calculator and I'll give it to us in our simplest form. Okay, so it'll be £0.025 per minute. Okay, so essentially our gradient is the cost per minute. Okay, now our answers in p's, okay, are in pennies. Okay, as we can see up here on our graph, the unit is in pounds, so we just need to multiply our answer by 100 and it'll convert it into pennies. All right, so that'll be 2.5p. Okay, I know what you're probably thinking, 2.5p doesn't exist. Well, it does in this maths question, so let's get moving. All right, and it does exist in the world of finance as well. So hence write a formula for the total cost of tariff A for m minutes. Okay, so how do I explain this concept? Okay, they're looking us to include m minutes. Okay, so how much would it cost us for 2 minutes? Well, it'd be 2.5p multiplied by 2, wouldn't it? Okay, so that would be 5p. What if it was 3 minutes? Well, it's 2.5 multiplied by 3, isn't it? Which would be 7.5p. Okay, so if I didn't know the minutes, I could just go 22.5 multiplied by m. Okay, m just being what I like to call a placeholder for our minutes. Okay, we don't know how many minutes the person's used, so we'll just put m in. Okay, and when we know how many minutes I've used, we could change m for that number. Okay, so this is why we'll use the variable m. So if at any point in time you want to know what the total charge is or the total cost per minute is, we can just use the placeholder m and insert. If it's 200 minutes, we can insert 200 for this m value. Okay, so t is equal to, I'm going to add in this 2.5 times by, or I'm just going to go 2.5m. Okay, now total cost, we also have to include our fixed charge per month. Okay, because we're getting charged that each month. Now I have put the unit of our minutes in pennies. Okay, our fixed charge months in pounds, so in this formula I'm going to convert it to be pennies as well, which will be 2,000 pennies plus 2.5 multiplied by the number of minutes that we have. Okay, so if I ever wanted to work out how much it would cost me to, say, if I call for 50 minutes per month, my total charge would be 2,000 pennies plus 2.5 pennies multiplied by 50, and that would give me a total cost. Okay, or that would give me my total cost. I don't need to work it out, but I'm just showing you how we would use the formula once we have created it. Okay, so hope that makes sense so far. Let's move on to the next question. All right, so expand and simplify. This is generally your FOIL technique. What I do is outer by inner, outer by outer, inner by inner, and inner by outer. Okay, so x by x, x squared, x by plus 5x, minus 3 by x, minus 3x, minus 3 by plus 5. Remember, we've got a minus multiplied by a positive still gives us a minus, so it'll be minus 15. Then we can simplify this bad boy down. We've got 5x minus 3x, which is just 2x. Yep, so our answer will be x squared plus 2x minus 15. Okay, So easy enough. Okay, nice 2 marks. So two cyclists start from the same location. Excellent. So it is. It sounds like fun. One cyclist travels due north. Okay, so they obviously don't like each other because they're not traveling in the same direction. One cyclist travels due north at an average speed of 22 kilometers per hour, and the other travels due east at an average of 26 kilometers per hour. Okay, so the northern guy travels at 22 km, eastern guy travels at 26 km per hour. Okay, how far apart are the cyclists after 2 hours? Okay, so we know that essentially what we know is the rate of distance that they would move per hour. Okay, so 22 kilometers per hour. So if we're traveling 2 hours, we would just double it. Okay, so our northern cyclist has traveled 44 kilometers, and our eastern cyclist has traveled 52 kilometers per hour. Okay, and we want to find the distance apart. So this is this hypotenuse of our triangle. Okay, so if you don't remember Pythagoras' theorem, it's h squared is equal to a squared plus b squared. Now some people write it as a squared is equal to b squared plus c squared. I think h is easier because we know h is the hypotenuse and a and b can be either side. Okay, so what I'll do is I like to rearrange my formula before I put any values in. So h will be equal to the square root of a squared plus b squared. So h will equal the square root of 44 squared plus 52 squared. Okay, so h will be equal to, let's take a wee look, 44 squared plus 52 squared, 68.12. Okay, I'm going to keep it to 2dp. All right, 68.12, and that's what we would expect. Okay, our hypotenuse is always going to be longer than the other two sides. It's the longest side in our triangle. Okay, so if you get a value that's smaller than 44 or 52, you know you went wrong. Okay, always expect a larger value. All right, so let's move on to the next question here. Okay, simplify 5 minus x plus 10 all divided by 2. Okay, so give me 1 second here. Sorry, I just had to turn off notifications on my phone. I get easily distracted, so I do. So simplify 5 minus x plus 2. Okay, so when I see this, or when I see any fraction and we see a negative, we want to have the same denominator. Okay, so what divided by 2 would give us 5? Okay, 10. Okay, 10 divided by 2, that would give us 5. Okay, so it's just turning our 5 into a fraction, and now we're able to work with our beautiful algebraic fraction. Okay, beautiful might be the wrong word for it, but anyway, now the minus is in front of our x plus 10. So what I'll do is I'm gonna multiply my minus through. So it'll be 10 minus x minus 10 all over 2. Okay, so 10 minus 10, it's just going to give us 0. So it's just going to be x minus x all over 2. Okay, an easy way to simplify it might be you'll take the half out. So it'll be minus a half x. Okay, there's another way of writing it. Okay, either way should be acceptable. Okay, so moving on to our next question here. A factory produces 3 types of light bulbs: clear, pearl, and color. Okay, so in a week they produce 45,360 clear bulbs. Okay, So I'm just going to go clear 45360. Okay, we also have pearl and we also have color. I'm going to go call for color, C for clear. Okay, so this pearl and color makes up 36% of the total produced each week. So if pearl and color make up 36%, then our clear would make up 100 minus 36, which would be 54%. I'm doing that mental maths. Nah, it's not 54, it would be 64. So it would be okay. As I said, sometimes the mental maths isn't great. Yeah. So 64 plus 36 is 100%. So our clear is 64% of the total produced each week. Okay. Now it gives us a ratio 4 times as many pearl colored or pearl produced as colored. Okay. So we have a ratio. Okay. Pearl to colored, which is 4 to 1. Okay. So this will help us out for our question. Now it's asking how many pearl are produced. Okay. So I don't know how many pearl or how many color produced, but I know the percentage of them. Okay. And I know the percentage of my clear. Okay. So if I find out what 1% is, give me a sec. I've just written that wrong. So 45360 divided by 64, that would give me what 1% is equal to. Okay, so 1% is equal to 45360 divided by 64. That would be 708.75. Okay, so I could multiply it by 36 and that would give me both what pearl and color are, but I'm going to work with my ratio here. I know that I have 4 to 1 in terms of pearl. Pearl is 4, color is 1. Okay, so what I'm going to do is I'm going to divide my 36 by 5. Okay, if we have a ratio of 4 to 1, we would add those two together and we can divide that into our percentage, which would give us 36 divided by 5 be 7.2%. Okay, so 1 in our ratio would represent 72%. We're looking for what percentage of pearl that we have, so we'll multiply our 7.2 by 4. Okay, so 4 multiplied by 7.2 gives us 28.8% for pearl. Okay, so I know that in total there's 28.8% of the total produced each week is pearl. I know what 1% is, so if I want to find out how many pearl were produced, I'm just going to multiply 708.75 by my 28.8%. Okay, and that'll give me the total amount of pearl produced in that week. Okay, so the total number of pearl produced is 20,412. Okay, pretty straightforward question. Best way to approach it is by breaking it down, just like I've done here, breaking down the percentages. Okay, and if you're having difficulty doing mental math on a particular day, just grab your calendar. Okay, it's more than acceptable, as it is a calculator paper. Okay, but I would try your hand at doing most of it by mental math, because M8 and M7 are both have non-calculator parts to them. So okay, now I've come to another frequency table. Excellent. All right, these are very easy questions. Generally speaking, they're easy marks. Okay, because it's the sort of repetitive stuff that we've just done. We've seen the previous frequency table. On up here. So it's the same sort of question. I imagine now that what we're going to be doing is we're going to be plotting a cumulative frequency graph. Yeah. Okay. So complete the cumulative frequency column. Okay. So again, number of pupils. This is our frequency. Okay. We can read the question. So 180 year 11 pupils in Glasgow High School. So 180. I know that's the total number of pupils. So that'll be my sum of F will be 180. We're asked to record how much time they spent on their phones on Saturday. Okay. Probably spent their lifetimes on their phone. So it is. So much interesting stuff to watch now on YouTube and TikTok. So let's take a look here. Okay. I'm just going to populate my table in general. Okay. So time t in minutes. This is, as we referred to in our previous frequency table, this is just our midpoint. Okay. So 0 to 30, our midpoint would be 15. Yeah. And I know it's going up by 30 each time. So I'm just going to add 30 on each time. Okay. So 30 add 15, that would be 45. 45 plus 30, 75, 75 plus 30, 105, 105 plus 30, 135, 165, 195, and 225. Okay. Now our cumulative frequency, again, we start off with our first frequency value, which is 6, and we'll add each frequency value as we go along. So 10 plus 6, 16. 25 plus 16 would give us 6 plus 25 give us 31. 31 plus 10, 41. 37 plus 41 would give us 78. 78 plus 32 would give us 110. 110 plus 29 will give us 139. 139 plus 27 will give us, let me think, 20 odd, yeah, 1/5, 166, and then 180. Add 14, 180. Okay, so we have this lovely cumulative frequency table. Okay, and what I'm going to do is I'm going to pause here and I'll plot the graph. So I'll see you back here in about 2 minutes time. Just in case you're unsure what we're plotting, okay, I thought maybe I'll show you the first 2 points just to give you a bit of know-how as to what I'll be doing. Okay, so I've just screen captured the results here and I have another screen, so I'm just going to put it on my other screen. Okay, so the first point, if we look up, is 15 and the cumulative frequency value is 6. Okay, so I have 1, 2, 3, 4, 5 across. So 20 divided by 5, each block represents 4. Okay, so and for my cumulative frequency I have 5, 10. So 20 divided by 10, each block represents 2. Okay, so the first value was 6 on our cumulative frequency, which is our vertical axis here. Okay, and 15 on our time. Okay, I'm just going to do a rough estimate here. So 4, 8, 12, 16. So close to 16. I want to get 6. Okay, so we're just about here. Okay, next is 45. So this would be 44 here, 45, and our cumulative frequency is 16. So 10, 12, 14, 16. Excellent. Easy enough. Okay, so I'll come back to you once I have wrapped up this graph. Okay. Okay, so I've wrapped up our graph here. Okay, now you should be able to see just done wee dots, okay? Now, I recommend you do the same. If you do X's on your chart, that's generally not accepted, okay? Just do a wee dot and a wee dot and just a wee circle around it, okay? So you're going to try to see me draw this freehand, okay? We've done a cumulative frequency graph. We're going to join up all the points, okay? Now again, I'm drawing on a drawing tablet and I don't have the best freehand drawing, okay? So your curve will probably look something like an S curve, okay? This is generally what cumulative frequency graphs look like, and you can see it kind of looks like this, and so it does. It's just I'm very bad at drawing it, okay? So this is what it should look like when all your points are plotted, and you'll put your line through all your points, okay? So now we're gonna use the graph to estimate the median, okay? So our median, as we did before, n plus 1 divided by 2. N is the total number of people we have. Now we have 180 pupils, so plus 1 divided by 2. So it'll essentially be 60.5. Okay, that's where we'll find our median value. And we'll look at this is for our cumulative frequency. Okay, again. So 60, you can even, right there. Haha. Not 60.5, excuse me, I'm thinking 120 plus 1. 180 plus 1 would be 90.5. Okay. I need to get my morning cup of coffee in me. So I do. So 90.5, this would be 90 here. What we'll do is we'll just go straight across. Okay, again, I'm trying to draw freehand. You'll have a ruler, draw the ruler across, and then we'll find our median time value going down the ways here. Okay, so it'll be in around, maybe in a range of 120 to 116. So I'm going to go 118 minutes. Okay, that'll be our median. Now again, mine's not accurate. Look at that bad boy. That bad boy is as curvy as a roundabout. So it is. Okay. So in your own test, use a ruler. For mine, just so you can see what I'm using, drawing tablet. Okay. Not as easy. There are tools, but I'm also lazy, so I'm not going to use them. I'm just going to go straight forward. All right. So interquartile range, okay? So interquartile range would be you have what's called Q1, Q0, Q1, the median, Q3, and Q4, okay? So our interquartile range is the range between these Q1 and Q3 value, okay? So if from our Q0 the median is, let's just go 90, okay, we'll round it down to 90, then from here to here is 45, okay, this is our quarter value, okay, so from Q1 the median will be 45, okay, so this will be our value here, 45, our median is 90. Okay, so our Q3 will be 45 plus 90, which would be 135. Okay, so what we'll do is we'll go up and see where our 45th value is, which would be around here. So I'm going to draw that across and go down, and then we have our Q3, our quarter 3 value, which is 135. So this would be 130 here, 2, 3, and around here. So again, I'm going to try my best to draw across, but you can see I'm having extreme difficulties. So, and then we'll draw this bad boy down as best we can. Just going to try to keep it in the middle. So it is. Again, freehanding is not the best option. In your case, a ruler is the best option. So I'm going to just call this our Q1 and our Q3. Okay, so our Q1 time would be 4 minus 80, which is about 76. Okay, and this will be in between 160 and 164, so 162. Okay, now IQR is equal to our Q3 minus Q1. Okay, so it'll be 162 minus 76. Okay, which is then equal to 62 minus 76. It'll be something like 94, 86. 86 again. If your mental minds ain't warmed up, just use the calculator. Alright, so it'll be 84 minutes will be our range. Alright, so the staff at the same school were asked to record the time they spent on their phones on the same Saturday. Well, we know the staff are going to spend the majority of their time probably on Facebook because that's what parents do. So their results are recorded in the box plot diagram. Alright, so if anybody doesn't know what a box plot diagram is, I'm just going to break it down right now. So it is, this will be our Q0 value, this is our Q1, okay. This line in the middle represents our median. This line here represents our Q3 value, and this line here represents our Q4. So this would also be our lowest value and our highest value. Okay. Box plots are very good for giving us the information visually. We don't have to think much. Okay. I know the median time is at probably, let's say it's about 20 across here, so it'll be about 4 each, so it'll be about 84. Our median is at 84. Our Q1 is at about 60 minus 4, so about 56. And our Q3 is about 124, 128, 132. So 132. Okay. So compare the results for the pupils and staff. Okay, Jenny wanted to ask us a question like this. What we'll compare is median, range, and IQR. Okay, so first let's take a look at the median. So pupils spend 118 minutes, staff only spends 87 minutes. So pupils have a higher median than staff. Makes sense, yeah? So, next thing, range, okay? Our range, our lowest value is 20, our highest value is 160, so our range for our staff is 160 minus 20, which is 140. Okay, so let's look at the range for our pupils then. Okay, so the range for our pupils would be, if I look here, time t. Okay, so the lowest time spent and the highest time spent, so our range would be 225 minus 15, which is 210. Okay, so our range is higher. The amount of, so essentially the amount of time that the pupils spend is more. So pupils have a higher range than staff. Okay, last thing, IQR. So our IQR for our staff would be 132. our Q3 value 132 minus our 56. So 132 minus 56. I can already tell that their IQR is lower. Yeah. So their IQR is 76. So just to change things up, staff have a lower IQR than pupils. And it makes sense, okay? Pupils have more free time, probably less responsibilities, so pupils would probably spend more time on their mobiles, so they would do. All right, so let's move on to the next bad boy here. Okay, solve a quarter, open bracket, y plus 3 close bracket minus 2 is equal to a half, open bracket 3 minus 2y close bracket. Okay, for me, I want to get rid of the fractions because that just makes my life awkward. Okay, so I'm thinking, what can I multiply through my equation? So both sides. When you're multiplying through, it means that you're multiplying both sides. That will get rid of a quarter and a half. Okay, I'm thinking 4. Okay, 4 will get rid of my quarter. 4 multiplied by a half will give us 2. Okay, so our new equation will look like y plus 3. Now remember, we're multiplying everything on this side by 4 and everything on this side by 4. Okay, so this, we've multiplied the 4 through here, so we'll just have 1 in front of our y plus 3. Our minus 2 gets multiplied by 4, so it turns into minus 8. Our 4 multiplies by our half, so it'll be 2, 3 minus 2y. Since these are multiplying, if you multiply the 4 through the half, it counts as multiplying through the whole. Okay, so we have y plus 3 minus 8 is equal to 2, 3 minus 2y. Okay, looks a hell of a lot easier. Okay, generally when we're solving algebraic equations, we want letters on one side, numbers on the other. Okay, so let's expand. Y plus 3 minus 8 is equal to 6. I'm just going to multiply through. 2 multiplied by 3, 6. 2 multiplied by minus 4y is minus, or 2 multiplied by minus 2y is minus 4y. So we have y is equal to or y minus 5. My head already jumps ahead. So y minus 5 is equal to 6 minus 4y. Okay, I want my y's to be positive, so I'm going to take my y over to this side. Okay, so it's a negative on this side. I'm going to add 4y to that side, so it'll be 5y. And so what I'll do, just to visually represent it for you, I'm going to take this bad boy is going to come over, and the minus 5 is going to come over. Okay, so that'll give us 5 comes over, it becomes a positive. 5 plus 6, 11. 5 is multiplying y on this side, so it'll divide on the other side. So y is equal to 11 divided by 5. Okay, so our answer for y, 11 divided by 5. Okay, or you can go 2.2. Okay, but I would prefer the fraction myself. Pretty sure it's 2.2. Anyway, let's move on to our next question. All right, so u has coordinates -1, -1. Okay, and v has coordinates 2 and 5 as shown. Okay, find the equation of the straight line that joins u and v. Okay, so what I'm going to do here is I'm also just going to try and join these points up. As you can see, I'm having a great time here trying to draw. Let me rub out these lines. Yep, and let me just do one line straight through. Okay, so there's two ways that you can do this type of question, okay? So there is, or at least there's one way to do it, and there's two ways to find a certain variable in it, okay? So the general equation of a straight line is y is equal to mx plus c. M represents the gradient and c represents our y intercept. So where it cuts the y-axis, okay? So if you had a ruler and you had a line, you drew through it, you could see that our y-intercept would be at 1, okay? So our c should be 1, okay? So I'm going to write that up there. C should be 1, okay? But we'll see as we go along, all right? So we want to work out our gradient. Our gradient is the equation for our gradient would be y2 minus y1 over x2 minus x1. So it's the difference in the height divided by the difference in the width, okay? So it's essentially your rise over run, but this is the general equation that we would use for straight line graphs, okay? So I'm going to write my points here, V and U. I'll give my U a wee flick, so I will, just so I know the difference, all right? My V is 2 and 5, and my U is -1, okay? I'm just going to choose this to be my x2 and y2. Again, me being preemptive, I wrote y on top of the x. So x2, y2, and this would be x1, y1, okay? Your first value in these coordinates is always your x. Your second is always your y, okay? So our gradient is equal to 5 minus 1, okay? All divided by, I'm just going to write x2 is 2 minus 1. Now, minus and a minus, these cancel and these just give us pluses, okay? Minus by a minus gives us a plus, okay? So it'll be 5 plus 1, 2 plus 1. So our gradient will be 6 divided by 3. So our gradient is 2. So again, gradient m is equal to 2, okay? So now that we have m equal to 2, we can write y is equal to 2x plus c, okay? And if we don't have a visual indicator or a graph that's plotted, what we can do is we can put our coordinates into our equation to find out what plus c is equal to, okay? I'm going to choose v, okay? So I'm going to put v into my y is equal to mx plus c, okay? So v is 2 for x, 5 for y, okay? So on our y equals mx plus c is y is 2x plus c, okay? Just given the general equation, okay? So it'll equal 5 for the y is equal 5 for the y, and then I write the y. 5 is y, and it's equal to 2 multiplied, 2 is the gradient, 2 multiplied by 2, because that's our x value and our y value, okay, plus c, okay? So 5 is equal to 4 plus c. We take our 4 over, it becomes negative. 5 minus 4 is equal to c. C is equal to 1. Now, you can see, you can either get it visually from the graph where it cuts the y-intercept, or you can work it out by putting a point on the line into your y equals mx plus c equation, so long as you have found your m. Okay, so let's move on to the next part. All right, so find the equation of the line perpendicular to uv that passes through the point 0, 1. Okay, so perpendicular, essentially what that means is it's coming in at a right angle. Okay, so if I was to visually indicate it, okay, passes through the point 0, -1. So it passes through this point here, and visually it'll be at right angles. Okay, so this will create a right angle. I know I haven't went through the point, that's just me being bad at drawing. Okay, and when it says that it's perpendicular to our UV line, okay, what that actually means, okay, is our gradient is going to be what's called the negative reciprocal. Okay, so essentially if we have a line 1, okay, and we have line 2, which is, give me one sec, explain a bit better. So if our line 2 is perpendicular or at right angles to our line 1, then our m goes to 1 over -1 over m. Okay, so essentially our gradient will be what's called a negative reciprocal. Okay, we'll just put our m value in. Our m value is 2, so 2 goes in, -1 over 2. Okay, so our new gradient for this, our gradient for this perpendicular line is -1/2. Okay, so this is the first part of the equation. Now this is why they've given us a point 0 and -1. Remember, 0 is our x, -1 is our y. We can put these values in to find our plus c. Okay, so x is 0, so -1 is equal to c. Okay, now we can already see 0 -1, that's where it cuts the y-axis, so it would be the y-intercept. Okay, so our full equation would be y is equal to -1/2 x -1. Okay, and that should be us done. Okay, now if the question says the line is parallel, I'll probably spell parallel wrong, but that's okay. Your m is the same. Okay, it's not different. If it's perpendicular, we'll apply m is the negative reciprocal. Okay, just for example, if you're trying to understand what the negative reciprocal is, if we have 1, or 1's a bad example, if we have 2, the negative reciprocal of 2 would be -1/2. The reciprocal of 2 is 1/2. Okay, so negative reciprocal is just a negative added on. All right, so hopefully that makes perfect sense. So it does. So that's our equation there, and we actually need to finish off this one here, 2x plus 1. Okay, I didn't fully write it. If you don't fully write it, you'll not get the marks. Okay, so make sure you have written the final equation for each of your lines. Okay, so let's take a look through at our next question here. Okay, find an expression for n for the difference between the two areas of the squares. Okay, so find an expression in n for the difference between the two areas of the squares. Okay, so squares have the same lengths. All the lengths are the same. So here we go. Now find an expression for the difference between the areas. Difference generally means we're taking away. So what I would do is I'm going to go 4n plus 3 all squared, because if you're working out the area, it's length by breadth for squares. Length and breadth are the same, so I'm just going to square it. Okay, minus the square of our smaller square, which is 3n plus 4 all squared. Okay, now just in case you don't know what a square represents, in this context it just means that the bracket is multiplying by itself. Okay, so like that. So I'll write it like this because that makes it easier for me. All right, so I'm gonna expand the bracket. Okay, so expand the bracket if you want, just so we have all the working out for you to see what I'm doing. I'll do the expansion of the brackets over here for our 4n plus 3. 4n multiplied by 4n gives us 16n squared. 4n by plus 3 is 12n. 3 multiplied by 4n, another plus 12n. 3 by 3 plus 9. Okay, so we'll have plus 24n, 16n squared plus 24n plus 9. Okay, and we'll do the same for our 3n plus 4 here. Okay, so 3n by 3n, 9n squared, and 3n by 4 plus 24. Okay, I know 3n by 4n is 12, 4 by 3n is 12, so I'm just multiplying my x term by 2, because I know the multiplication is the same. It's just like up here. 4 multiplied by 3 gives us 12n, 3 multiplied by 4n, 12n. It's the exact same situations happening here. Okay, so 4 by 4 plus 16. Okay, so now let's insert these in to our equation again. Okay, so 16n squared plus 24n plus 9 minus 9n squared plus 24n plus 16. So this minus is going to apply to all of our terms here. So what's going to happen is we're going to have minus 9n squared minus 24n and minus 16. Okay, so 9n squared, 16n squared minus 9n gives us 7n squared. 24 minus 24 gives us 0n, and 9 minus 16 gives us minus 7. Yeah, so simplest way to write this would be take the factor of 7 out, n squared minus 1. Okay, now I don't know whether this is required, but n squared minus 1 is actually what we'd call the difference of two squares, dots. Okay, so it'll actually be equal to 7n plus 1 and minus 1. Okay, so this is, I don't know whether we need to simplify it as much as this. I think this should be acceptable. If not, if the examiner's looking you to determine, oh, this is the difference of two squares, just in case you don't know what the difference of two squared is, for example, x squared minus 25, if we have any squared number, no x term, but we've got an x squared term, we can simply write the plus and minus of this squared term. Okay, into our two brackets. So same situation here. I've got n squared minus 1 plus 1 minus 1. If you expand, you'll get the exact same thing as what's inside this bracket here. Okay, so these are our two factors. X is minus 5, x plus 5. In this case, it'd be n. Since we're not equaling it to anything, we don't have any values for n. Okay, but that should be that. Okay, so let's take a look at our question 13. Okay, just give me 1 second.